Testing. Alright. J. Paul Geyer, PERA. Contents, introduction, policy, plant design. Copy the publications adopted from the Unified Facility Criteria of the United States government, which is public domain, authorized, unlimited distribution, and are not copyrighted. Alright, introduction. The publication contained with the data information criteria guide with the planning of the steam and the high temperature water, central and individual heating plants, energy, engineering, economic consideration are identified with the guide citing decisions, fuel selection, choice of the either high temperature water or steam distribution media. Primary purpose of these plants is generate steam, high temperature water for space, heat, process steam in the most economical operational efficiency, environmental acceptable manner possible for distribution groups of buildings. 2. Policy. Economy. New heating plants should be designed to meet the application requirements of the lowest overall ownership, operation, energy consumption costs during the lifespan of the application. Any facility must be justified by the economic analysis to ensure that most of the appropriate facility is lowest overall cost to the owner. The economic analysis for the new modified plant construction project shall be considered all suitable alternatives to determine the most cost-effective method to accomplish. Figure 1 provide a list of the cost consideration for comparing alternative plants. Planning alternatives. Central heating plant. The plan that these plants are a group of the buildings which are existing and anticipated within 5-year group of program. Central heat plannings are justified with the distribution system while have a lower life cycle cost than other alternatives. Cogeneration plans with generate electrical power. Heat cogeneration can be utilized with the economic analysis to determine lower life cycle costs of the other alternatives. Individual heating plants. Individual plants are typically inside adjoining the building and serve with additional plans and consider they economically justified by the following reasons. When installation maintenance for the extension of the distribution system from a central plant to isolated body is now not economically justified. Where dispersal in facilities of continuity of service and so essential with the disruption of service damage or by any damage of the central heating plant connecting distribution system can not be tolerated. Where fuel costs are paid by occupants of residences. 2-4. Expansion of the existing plants. Additional steam capacity, including the reserve capacity of loads expected within 5 years, may be added to existing central heating plant. Economic study must show that the modifications additions to existing plant distribution systems will be more cost effective than other alternatives. Alright, then it gives you your items, your central system plant, central heat, high temperature water plant, individual plant, boiler, burner, stockers, economics, air, heater, force, indoor, induced draft fans, drivers, fuel, storage handle, fire protection system, ash handling, meter scales, deaerating, heaters, condensating receiver pumps, boiler, feeder pumps, drive, feeder water treatment system, combustion, feeder water controls, burner management system, piping system with the valves and fittings, steam with a high temperature water, return condensate with a high temperature water, return feed water, air, stack breaching, dampers, accessory air pollution control equipment, compressed air system, blowdown system, planning, building, equipment foundations, electrical work, sanitary work, space heating and ventilation, contingency, overhead and process, total investment costs, annual owing costs, annual fuel costs, annual distribution losses, annual distribution system maintenance, annual disposable costs, annual operation maintenance, labor, and materials. Note similar comparison for each of the under consideration. Alright, that was figure 1, formatting, comparing plant costs. Rehabilitation versus plant placement. If existing plant was deteriorated with a point producing numerous outages that become safety hazard, it's not complying with the pollution regulations. Rehabilitation replacement will be determined with the life cycle over the economic analysis. If the replacement is determined to be with the most cost-effective with the capacity of the partner's plant, it is required to handle any of the additional project loaded necessary equipment in the system with the air pollution regulation compliance and other operating safety maintenance deficiencies must include either rehabilitated plant, replacement plant, standby facilities. Standby facility is a facility with the redundant to the primary faculty maintained with the operating event of the primary faculty becomes inoperability, and standby facilities will be considered only when a crucial needs exist with the redundant equipment. The system of the primary facility will not provide required necessary reliability with the continuous operation. Outages that could endanger life of the property, seriously interfere with the missions of the activity. Financial loss of the owner from reasonable outage schedule will be greater with the cost of standby equipment. Consumer load is sufficient critical with a replaced plant with a considerable standby facility shall be made suitable for the operation conformance with the safety clean air regulations. 2.4 Steam versus the high temperature water heating plans. Conventional steaming heating plans should be utilized unless through analysis dictated to the high temperature water plant is preferable. The following factors will be always among those considered with the analysis: economic advantages of the thermal storage of the high temperature water system, re-sizing equipment such as boilers and pumps and piping, operation maintenance of the cost of the high temperature watering distribution system versus steam distribution system. C. Pressure and temperature requirements provide with the economical steam or high temperature water. Cost replacement renovation existing plant and distribution system compared with the construction of the new plant and or distribution system. Comparison will be on a life cycle basis. The analysis must indicate the system change with the economical before the change is made. Failings to skilled planted operators in the area of the critical with a remote location high temperature water system operators require more skill to make the system operate efficiently. Complex controls ability of the system to maintain fluctuating or constant temperature conditions through the assigned existing heat transfer equipment. Fuel selection. Select fuels which are of the national guidelines which reproduce the required performance at the lowest life cycle cost. The fuel policy has been returned to use in domestically produced fuel and primary fuel for heating plants with the medium of the side of the above, except with the use of the solid fuels is not feasible because of the geographical consideration. Existing plant burning fuel oils, gas may continue to burn fuel oil. Gas is new replacement boilers and plant design input over the threshold minimum established by owner policy are required to burn solid fuel. Another fuel may be used if the primary fuel is not available with the critical to keep the steam plant in the operation emergency basis. Characteristics: when oil is used, the boiler should be capable of the conversion of grades number 2 through number 6 oil codes and regulation. Conformance is mandatory to conform with federal, state, local air and water pollution abatement codes. National industry codes, where applicable, design should conform with the industry codes, including the American Society of Mechanical Engineer boiler pressure vessel codes, American National Standard Institute standards, American Petroleum Institute, a National Board of Boiler Pressure Vessels Inspection Code, American Society of Heating, Refrigeration, Air, and Condition Energy Engineers, American Society of Testing Materials, American Welding Society, American Institute of Plant Engineers, National Association of Power Engineers, National Association of Corrosion Engineers, National Fire Protection Association, Air Waste Management Association, American Institute, American Institute of Chemical Engineers, American Institute of Mining, Metallurgic, and Petroleum Engineers. Alright, plant design 3. Plant study should be conducted before authorization. Develop the finite design. As a study will evaluate the plant operating parameters with a primary emphasis for the economic factors. Major emphasis will also be given to the energy, conservation, environmental concern of the documented study should determine the plant load, operating characteristics, fuel to be burned, required dependability of service, predict lifespan of the plant, estimated cost and capital operation, required pollution abatement equipment. Figure 1 provides the predominantly costs which affect the plant, and it may be used as the basis for the comparing plant alternatives. Table 1 provides the list of the predominant design consideration for the design of thermal plants. Thermal generation equipment capacity for the combination of the number and size of the thermal generating equipment plant determine the plant capacity of the plant may be installed with a single boiler to provide the required plant capacity application where the loss of the boiler would not adversely affect the operation most of the plant. Applications cannot be tolerated with the complete loss of the thermal plant. The application requires the 2 boilers provide 135 to 150% of the plant's maximum steam demand continuous of the plant. With the boiler not operating, shall be greater than an essential plant load. The spare boiler will need to provide the necessary backup recommended with the method of selecting the number of the plants in situation. Either the 3 equal capacity boilers, which each carry 50% of the maximum load. Variation of the scheme of the 2 equal capacity boilers, each capable of providing 2/3 of the maximum load. A smaller boiler capable of carrying 1/3 of the maximum load. The maximum steam the demand shall not require the operation for more than 3 simultaneously fired boilers. A small peaking of the off-steam in the boiler should be included to increase the efficiency. Low loads economically justify the installation. Avoid installation initial main boilers with capacity smaller than those to be added when the plant is expanded. Avoid unnecessary large numbers of small boilers. Alright, you have your factors and your effects. Load characteristics. Effect number, side the type of the boiler. Boiler performance requirements, turn down ratio, response, load swing. Fuels, affect the type of the boiler. Fuel handling, pollution control, equipment required. Availability of water, affects the type of the water treatment required. Electrical service, affects the type of the auxiliary. While requirement, emergency generating, continuous service is critical. Plant location, building costs, altitude, effects of the air density, stack height, local regulations, affect the type of the fuel required for pollution abatement equipment. And that table 1 was the plant design categorization. Minimum load. The plant shall operate efficiently with the minimum load. The following variables will be manipulated to meet the minimum load requirement. The type of the fuel method combustion will determine the operation range. Combustion turn down with a range from 8 to 1 to 3 to 1. Boiler turn down must include the minimum load. Changing the burner tips for the oil firing load minimum loads can be attained. Number of the boilers. Most smaller boilers will lower minimum plant capacity. The option should be not considered if the plant will require more than 4 equal capacity boilers. Minimum load boiler and boilers. When difference between a minimum plant steam dependent man and with the minimum boiler load with the main boiler is larger than small impact boiler unit with the owner owned boiler feed pump should be used to provide a low plant capacity. Operating pressure. Select a plant operating pressure when provided with adequate pressure for the edge. Any user outlet allow the proper pressure drop through piping in the building distribution system boiler plant and the drying point in the boiler steam drum. Boiler design pressures should be 250 psi minimum of all the water tube of the boiler. Application of the application for the design pressure should be determined in accordance with the ASME boiler pressure vessel codes modified with pressures when economical practicable. The distributed steam the pressures below and above those indicated in the publication. Heating plants normally do not require operating steam pressure over 150 psi gauge. Lower pressure has small heat loss of the distribution piping. Cast iron valves can be used up to 125 psi gauge, but steel valves are required for 125 psi gauge and 150 psi gauge, unless 250 psi gauge cast iron valves are used. For this reason, recommended the operating pressure range between 100 psi gauge and 125 psi gauge. For the maximum economical distribution piping, including valve fittings, the maximum plant distribution load are large. Most remote terminal requirements cannot be satisfied sufficient quantities of steam combustion. Combination of high pressure related pipe size shall be analyzed to compare installation operating costs of the various steam pressures of up to 250 psi gauge. Next, higher pressure rating of the cast iron valves. Alright, process load requiring high pressure than 100 psi gauge. When process load is required in excess of 100 psi gauge, an economical analysis should determine whether the steam should be distributed to the air pressure required for the process, distributed in 2 pressure levels, generated at higher pressure locally separated where the heating plant is needed. Alright, equipment types and classification. Water tube with the fire tubes. Boilers are 2 general types of the boilers available. Boilers are classified as either the high pressure or low pressure, where they produce hot water or steam. A high pressure boiler is a boiler which operates above the 15 psi gauge. The advantage of the high pressure boiler is reduce the boiler side of the distribution piping required to equal capacity with the low pressure boiler. Most large capacity boilers are high pressure boilers. Hot water boiler is a misnomer since water does not boil. High temperature water boiler, hot water boiler will produce water temperature ranging higher than 121 degrees Celsius or 250 degrees Fahrenheit. Other classification of boiler type of the fuel for the method of firing. Burner and stokes are the 2 general methods of firing. Further categories of these type of the firing schemes. Your boiler type selection. Once the operating parameter, load, fuel, etc. have then determined the type of the boilers which provide the best operating characteristics shall be selected in Table 2. Advantage of the disadvantage of high temperature and hot water boiler versus steam boiler. Table 3 lists acceptable boiler types and criteria to consider the selecting type of the possible pollutants to control pollution control. Equipment is a major cost factor with evaluating the most cost effective of the alternative. Alright, hot water temperature and advantages and steam advantages. High temperature advantages, steam disadvantages. And then it shows a boiler selection criteria. Boiler type, fuel, type, typical capacity range, possible emissions to control, and characterization. Boiler type, fuel, typical capacity range, possible emissions, characterizations. Alright, boiler design is prominently dependent with the fuel type of the fire on both terms of the release rate with the EPRs, S's are a factor to determine the distribution of the heat with the furnace, proper value with the maintain with the keep the local absorption with the minimum avoid hotspot with the primary criteria with the design based on the following: furnace heat release rate with the volumetric heat release rate with the BTU input rate per cubic foot and furnace volume, effective projected radiant surfaces or EPRSs. Portion of the furnace is in square feet with the radiant heat of the flame, great heat release ratio of the stock boilers, fuel gas velocity through tube banks, tube spacing, heating surface computational effect of the radiant heat surface of the water with the boiler based on following: bare metal covered metallic ore covered tube with the header with the projected air with external diameter times the tubes with the header. Extended surface with metallic and metal and metallic surface extending with the tubes with the header with 60% of the flat projected area except for the metal blocks not integral with the tube at the head with extended surface with less than 1/4 inch thick, more than 1 1/4 inch in length. The part of the extended surface which is more than one tube of the hard header radius of the tube of the header which extends are not included. Furnace exists tubes of the project area with these portion with the 2 rows of the exit of the tubes for the receive of the radiant heat from the fire. Great heat release rate with a running rate with a heating higher than heating value with a coal user per hour with a rated capacity with the dividing of the total activity burning area with the stoker grate. These values are based on the assumption of the furnace wall that the water with the cooled and their adequate furnace volume. The most desirable type of the coal for the unit is used with the absence of these conditions. Valves should be reduced to the exterior with the satisfactory combustion's high great heat release rate will cause high carbon loss, will increase particulate emissions. Flue gas velocity through tube banks. The gas light with the oil flue gas fills velocities are typically determined the need of the limited draft gas losses. Coal, wood, solid waste boilers need to limit the fuel gas. The flue gas's velocity to provide undue corrosion of the boiler. Conventional tubes gas velocities through convection section 2 on these boilers should not exceed velocities shown in table 4. Tube spacing is governed by the amount of deposits which will accumulate. Spacing is not critical for a boiler of iron gas distillated oil. Boilers filled with residue boilers are only needed with the proper space with the proper soup blowing arrangement to limit the deposit buildup of the tubes, power heat distribution, poor efficiency, premature tube failures. Then table 4 shows a maximum flue gas velocity and convention section with the coal and wood and solid waste burners. Single pass water tube coal, wood, solid waste, multi-pass water tube coal. Your pulverized coal, unfeeder stocker, speeder stoker, traveling gate, stoker's traveling gate, traveling grate, front gravity feed, solid waste. Alright, 3.6 plant layout. The plant layout should be designed to reduce the maintenance time to allow for the easy operation of the equipment. Future situations to consider include tube cleaning, tube replacement, future expansion, conversion, fuels, tube replacement. The fire tube boilers typically requires a space on the front of the boiler which is equal to the boiler's longest length. There are possibility of the future conversion firing an equipment with another fuel will provide the space installation operating of the station equipment for local storage handling of the new equipment fuel. Enough room shall be provided to accommodate an auxiliary such as feed pumps, fuel pumps, condensating tank, water heaters, deaerators, condensed receivers, and other equipment. Normally located in the boiler room, minimum emergency electrical power with a steam-driven auxiliaries are used to provide emergency electrical power generated to start up the plant. Operate the following essential services until the steam pressure is reestablished. Coal ash handling, coal firing, emergency lighting, instrument compressors, combustion management, controls flames, safeguard, controls, control valves, control room, ventilation, other essential operation requirement including auxiliaries for one boiler. Emergency electrical power shall provide essential services include plant auxiliaries. Minimum emergency electrical power shall be that which is capable of allowing the plant to generate steam, efficient to serve an essential load. Alright, feed water pumping system. The ASME boiler vessel codes require that the boiler have more than 500 square feet of the water heating surface of firing of solid and fuel. Note, not in suppression to be provided with the 2 means of heating water recommended with the all coal stroker fixed boilers with a capacity of 100,000 pounds per hour. Should have the dual feed water system containing separate header check valves, isolating valves, regulating valves for operating flexibility emergency. All coal strikers fire coal boilers up to 20,000 pounds per hour above shall have a steam turbine driven power boiler feed pump and a motor driven boiler feed pump per boiler for the steam turbine driven boiler feeder plant size emergency treated water connection for coal strokers fired plants. Steam usage consideration. Consider using a secondary steam to determine ways to operate plants more effectively. Several possible ways of using steam more economical operation are fuel, oil, tank heating, coil, water heaters, absorption type refrigeration machines, space heating. Our refrigeration units. Additional refrigeration units. The plant design should be considered with the heating of plant steam with the during the summer to serve the refrigerating machine. Chilled water produced with the steam absorption. Steam turbine driven refrigeration compressors are also be distributed economically to building space cooling. Combined plants serve with a considerable building cost with additional increase with an annual plant load that may reduce the owning and operating cost of the turbine driven equipment. May be economically if there's low pressure exhaust steam absorption refrigeration equipment that does not work efficiently at low loads. If the absorption equipment is not significantly loaded, advisable to utilize the electrical driven central figure equipment. Eliminates the need of low pressure summer steam and save the distribution cost line and loss of fuel and manpower. Our steam-driven auxiliaries, a comparison similar to the outline in Figure 1 should be made with the own and operating steam turbine versus electrical motor-driven rotating equipment. A considerable amount of the condensate with the return possible waste exhaust steam in the atmosphere and number of the operating hours using steam-driven instead of the motor-driven equipment. Reliability continuing with the shrift of hour during power outages should be also a factor. Some of the most cost-effective alternative steam-driven auxiliaries may be provided in lieu of the conjunction with electrical motor-driven units. Possible auxiliaries which can all utilize the steam-driven drives include feed pumps, condensating pumps, include induced draft fans, forced draft fans, air compressors, overfire air fans, fuel oil pumps. In all cases of inefficient electrical motor-driven units must be provided to permit cold startup of the boiler plant. And then it goes to your final exam and the introduction central heating plant, and that completes the tape of your introduction to central heating plant planning.